All right, so today we're going to talk about the journey to the private cloud, but we're going to focus on an emerging technology from VMware called vSphere integrated containers. So as we go through this, we're going to start with some basics around containerization and then talk more specifically about how VMware is bringing containerization to your existing ESXi infrastructure. So what we're seeing in the enterprise today is really a confluence of four forces that are causing change in the way IT is delivered. The first is DevOps. This is really moving, instead of having silos of application development and then operations teams, it's really bringing those teams together to more effectively deliver your differentiated software to the business. As well, it goes part and parcel with that is the Agile movement, where development teams are now moving from waterfall-based development, where there would be large monolithic releases a couple of times a year. And I think most operation teams that I've been involved with really dreaded those events because it tended to be these just horrible events, right? Everybody would go into a war room, spend an entire weekend, upgrading the software and making it work. With Agile, you really are trying to move a much smaller set of changes from your developer environment to production on a more regular basis so that you don't have those kind of massive monolithic events. And in support of those methodologies, we have a couple of technologies that have emerged as well. The first is containerization. So this is really largely led by Docker, but there certainly are many other formats out there. And then microservices. And what this is taking those large, for instance, a three-tier enterprise app, right? You have a web, some kind of a business logic tier, and then a data tier. With microservices, instead, what we're seeing is that you break up those services into much smaller microservices. So maybe the authentication service is its own service, whatever, right? It's broken up into a multiple of services that then all loosely communicate with each other through a REST API. And this facilitates the ability to upgrade these independent services, independently. So as we talked about, right, we're seeing this shift, and the other piece, right, to this shift from this monolithic architectures to microservice architectures is that we see really an explosion of the number of managed pieces, right, in your enterprise environment. If you don't get a handle on this up front, what happens is you end up with just a proliferation of microservice-based containers in your environment, and really no easy way to manage and really control that environment. So what we're seeing as we dig deeper into what businesses are looking at today, we're seeing two kind of key areas that are silos, just outside of operations, right? There's the traditional silos in some operations as well, but really from a business perspective, we're seeing a silo where the business has needs, right, for some kind of customization, a website, a product, some kind of a way to touch their consumers with technology. And those requirements and those ideas are generated on the business side. Usually it's a silo where they just get thrown over the wall, right, to development. And then development takes their best guess at what that functionality looks like and how to deliver that to the customers. And then you reach the next wall, which is when then development's done and we need to make this into a production app. And usually that code is just thrown over the wall again to operations, and then they have to make it work without a lot of input initially on how it's architected. So the two areas that try to address this really is Agile Development is really designed to kind of fix that business to development translation. So what the goal there is with Agile Development, you accelerate the feedback loop on features and changes within software through 2-week sprints. And within those sprints, you deliver a small number of features that the business wants, and then you can start on the next set of features. So the goal there is to minimize the backlog of feature changes. And then the DevOps movement is what we look at to really streamline that code handoff from the development teams over to operations and really have those teams work cooperatively to move that code over to production. So what is DevOps? It's much more than a technology. If anybody comes in and says, oh, we have a DevOps tool that's going to solve all of your problems, you just install this tool, be very skeptical of that. DevOps is far more than that. Certainly tooling is part of it, but really what I see is tooling is the least important part of it. The most important part is really the practices, the culture, the way the organization operates. Breaking down those silos is often the hardest part. And then moving that over where tooling then comes in after those silos are broken down to help those teams communicate with each other even better. So containers help here, and this is we're getting the meat of what we're going to talk about today, but containers really help here because they give you a single format that allow you to easily move code between dev, test, and production. And I would say at the heart of it is the goal of containers is to solve that age-old problem of, hey, it works on my laptop, but it didn't work in production. That you're using the exact same code and the exact same systems to run that code across the entire development spectrum. So if we look at Docker just as a technology, Docker has become kind of the predominant containerization technology out there in use today. Containerization existed a long time ago, right? We had Solaris zones way back, and that still exists today. Linux LXC, a lot of platforms of service offerings like Cloud Foundry use a containerization format underneath as well. But Docker has become largely the standard out there because they did a really good job of creating a portable file format, right? This file format of packaging up the application and all of its related binaries really changed and made it so frictionless for developers to build code and move that over to production that it's taken off like wildfire. So we'll get into a little more about how it actually works when we talk about vSphere integrated containers and how it operationalizes. This ecosystem as well is exploding right now. There's tons of startups. There's a lot of open source software out there. This is just an example of some, and I guarantee you almost every day there's a new entrant into this space. So there's a lot of technology, but there's a lot of immature technology. And that's really where VMware feels like we can add or augment this space. We didn't see there was a need to have another container standard to try to compete with Docker containers. Instead, what we saw is where VMware's expertise is really on enterprise management, right? Bringing technology to the enterprise. So we feel like with these technologies, we'll be able to make Docker so it can be operationalized effectively in production. So if we look at it, right, there are still a lot of challenges with containers because it is so immature, right? So containers in development, no big deal, very easy. There's not a lot of security requirements, etc. But when you go to move those into production, what we see is there are a lot of technologies that become a problem. The slide is acting a little bit weird. There should have been more blocks there, but you have things like security. Yeah, sorry.
I was just going to say, Adam, I think if you click again, they may appear if there are more there. Sorry to interrupt. Nope.
No, they won't.
There they are. Oh, and there they are.
All right, sorry about that. All right, so you have things like how do you deal with high availability with Docker containers? How do you deal with security, right? Because you're sharing a Linux kernel. Is that secure? Is that something we're willing to bet our business on? Disaster recovery, right? Monitoring. There's a whole, usually if you do just a native Docker container and you try to monitor that, most tools don't understand that technology. How do we handle that? How do we, account for these? How do we even know what's running in our environment? So there's all of these questions that are really the barrier right now that the startups have not figured out, and that's where VMware can add a lot to this technology. So that brings us to vSphere integrated containers. So vSphere integrated containers is VMware's approach to being an entry point for containers in the enterprise. And what we designed here was really a technology to augment vSphere and vCenter to enable you to give your developers access to containers on your existing infrastructure in a very frictionless way. So we'll dive a little bit into how that works. So there's a number of pieces to this. Like I said, it rides on top of vSphere. It also can work with NSX and vSAN and can be orchestrated by our higher level tools like vRealize operations and automation, all of those tools. It's meant to really just be kind of snap in to an existing environment so you don't have to create a silo for containerization. It supports all the industry-leading capabilities of DRS, vMotion, HADR, storage and network integration. You don't have to rebuild another architecture for this. So if we look at how it's different, right, what we see today, if you, in your environment, a lot of times customers will start out with containerization by going out and saying, well, I'm just going to create a big Linux VM, and I'm going to install Docker on that, and then we're just going to put a whole bunch of containers on that particular VM. And that's great, right? That approach works. But the problem with that approach is really three things, right? Number one, because Docker doesn't have a concept of shared storage, you end up with using a lot more storage. Even though containers are smaller than VMs, that because they don't have shared storage between hosts, you end up having those containers downloaded in a number of hosts, and they end up eating a lot of storage up. Then you have security concerns because those containers are all sharing a Linux kernel, right, on that base VM, and that Linux kernel it gets access to that Linux kernel through root level privileges. So if one of those containers gets compromised, right, so say you have a blog or some WordPress running on there, and then you have some business critical system with PCI data, for example. I know that's not probably a real world example, but just kind of illustrate the point. If that WordPress site were to get compromised on that host, because they would be compromising that container and it runs as root, they would in essence be able to traverse all the other containers on that host and have root level access to them, so they could access all the data on them. So that is the single biggest roadblock that I see across our customers to bringing containers into a production world, is that security concern. And then the last is really the management side. You have a lot of tools that know about VMs. They can monitor that VM effectively, but what you don't have then is the intelligence, right, in those tools to see down and see at the container level what's going on with each individual container inside that host. So you really lose a lot of visibility into those containers. With vSphere integrated containers, we take a totally different approach. What we do is we do what we call just enough VM. So we have a very small, in this case, it's about 25 megabyte Linux distribution called Photon OS. It's an open source product from VMware. We take that and we instantiate a VM container that just has that 25 meg Linux kernel running in it. And then on top of that, we then load or run a container one-to-one with that VM. So that eliminates the security concerns because you still have kind of the walling of that hard separation of the virtual machine, but you have the advantages of containerization in that you have the portability still. So it's really the best of both worlds. And then we do a couple of other things that we'll get to in one of the next slides around the other two concerns as well. All right. So how does this work, right? So we have the key building block for vSphere integrated containers is what we call the virtual container host. This is just a virtual machine. It's shipped as a virtual appliance, just an OVA file that you deploy into your existing environment. And this then becomes a virtual container host. And what that is think of it as a 100% Docker compatible. So it's using the Docker API. And advertising that API on top of ESXi. So then if you want to provision a container, you just do a Docker call to the virtual container host, and it will provision that container. So the developer doesn't need to understand things like vCenter, doesn't need to go into the web client, right? There's no need for that. They just use their existing tooling and just connect to this API endpoint that you give them, and then they can provision containers as needed. All right, so when we look at vSphere integrated containers, right, the management side of it is integrated into the vSphere web client. So as an admin, you basically create a virtual container host and then tell it how many resources it can have access to. For instance, you can dedicate a cluster if you want. but that's not really necessary. And most customers I'm seeing, that's not what they're doing. What they're doing instead is just allocating a resource pool inside of their vCenter server, and then allowing the containers to just have access to that number of resources. That way you can control so that your development teams can't go in there and kind of overrun your infrastructure and cause problems. You can still control how much they use without having to go through some approval process or things like that. So we have the virtual container host, and then this also leverages a technology that was introduced in vSphere 6 called instant clone. What this is, if you think of cloning, right, there's 3 different types of cloning in vSphere 6. There's the base level cloning we're all familiar with, where we just create a VM from a template. And then we had snapshots, right, where you could create linked clones from those snapshots so that you minimize the disk footprint of them. Instant clone is taking that to the next level. And instead of cloning it, based on a snapshot, what we do is we do a clone in memory of the VM. So we can spin up VMs extremely fast because everything happens in memory, and we essentially are deduplicating that memory. So we don't waste memory either. So we have these base templates that are 25 megabytes, and then we clone off of those. The other advantages with instant clone is that the machine you're cloning from is already running, so there's no boot time either. So basically what happens is we clone from the running VM, it's already booted, and then we just run a script in it to change the IP addresses, etc. And you can do that any number of times. So then when you provision a container, it kicks off an instant clone, and it fires up a Pico VM, which is just that small Linux kernel with the container inside of it. And then you can rinse and repeat. You can do that as many times as you would like and spin up VMs without the memory overhead of this one-to-one architecture. And the other nice thing here is that not only can you spin up containers, but inside of that same resource, right, on that same host, it doesn't have to be dedicated to containers. You can still run your traditional VMs with no changes. So it really gives you the best of both worlds. That's why we call it a frictionless entry point for containerization. If we take a look at it through the web client, the plugin that you would use, and this is, again, only really used for the admin side when you're setting it up. From a developer or an end user perspective, they would never need to access this info. But it's very easy. In what I'm doing today, you can set this up in 10 to 15 minutes, right, and begin testing and playing with the technology. It's very straightforward. You don't even have to manage that base template. When you install the product, it creates that base Photon OS template for you and deploys so you're ready to go right from the minute you turn this on. So this will give you some idea of the workflow, right, that happens when you do when you initiate a container with vSphere integrated containers. So from the end user's workstation, they would issue a Docker run command with whatever container they wanted to run. That would be sent to the virtual container host, and then from there, that virtual container host then talks to vCenter. vCenter that issues a clone command to vCenter. And then what we do is when you install, each host in the cluster you install to gets this Photon OS base template that's running. And again, it's very little overhead. It's a 25 megabyte VM, so don't think it's like some 4 gig, 4 CPU VM sitting there eating resources. But that's running on each host. vCenter then decides on the placement for where this should run based on resources, and then clones that VM, and then that becomes container 1 or C1 on the screen. That cloning process is extremely fast. On average, it takes about milliseconds to create that particular VM in the environment. Then what we do is another technology. I mentioned earlier, right, that we don't have shared storage in a container host world, traditional container host world. What we do is then when that container is pulled from whatever registry, it can be Docker Hub or it can be a private registry in your network, that image, those layers of that container are converted to VMDK files and stored on our shared VMFS data stores. That way, you now have access to shared storage across the environment. And then the last step is we take that image VMDK file that we downloaded and we shim that in to, in this case, VM C1, right, and start the container. So we just mount that dynamically to the Linux file system, so there's no copying into that VM, and then start the container and let it run. At the end of the process, right, if you do a Docker stop to stop the container, that powers off the VM. If you then run a Docker RM, which is the delete command for a Docker container, that then deletes the container and the underlying VM. So this environment not only makes it easy to provision, but it also makes it easy to keep it clean and not have a bunch of extra things running out in your environment. The last thing we said was a problem was management tools. And that just fixes itself through this because we're one container to one VM. So if you have a tool that already understands virtual machines to do the monitoring, it will automatically understand these as well because they're really just a VM with a single container inside of them. So it makes the management side much simpler. I think with that, I will just say vSphere Integrated Containers is available as open source. So we haven't reached GA yet with this product, general availability, but it is available out on GitHub. So it's github.com/vmware/vic. So you can download it and try it out. We're expecting to make this generally available later this year. But like I say, you can try it out at any point now, and just keep in mind that it's still being developed, so there's some functionality that's not in the base product yet. With that, I think we can take some questions.
Awesome. Thank you so much, Adam. Great presentation. Thank you for the updates, and certainly the link on where folks can go try it out is fabulous too. As a reminder, you can post questions to the questions pane, and we have time for a few questions. There are a couple coming in. First question, definitely for Adam. Are higher level tools such as Docker Compose supported with vSphere integrated containers?
Yeah, that's a good question. So in general, right, any tool that works with Docker will work with vSphere integrated containers. And the reason for that is that we didn't take and change the Docker, the API that we're using. It's still a 100% standard Docker API. So because of that, we don't have the we don't really have concerns about other tools that use Docker not being compatible. They should be 100% compatible, assuming they're API compliant.
Awesome, thank you. Looks like we have we're running a little bit long, but we have time for one more question before we wrap up today. Will vSphere integrated containers work with a private container registry?
Yeah, so you can use the public Docker hub, right? It'll be the default, but if you and your organization want to keep these containers internal to your environment, it certainly works just as well with a private repository as well. So either way, it's perfectly fine.
Awesome. And did you say, one last question, did you say there was a timeline for the GA version?
Yeah, I mean, nothing more specific than towards the end of the year. I believe if you pay attention VMworld-wise, there'll be some, a lot of information about that I can't divulge just yet.
Right. Awesome. We'll keep our ear to the ground and be sure to try and get the word out as we see more information later this year. Thank you so much. That concludes the Q&A portion, but before we let everyone go for today,